seen in this unit will come under the Maxwell equation. So displacement current is going to play a step towards your Maxwell equation, one of the Maxwell equations. Okay. So I think we all know del cross H vector is equal to J vector plus N vector. Okay, current density element J vector. Okay, so H vector is nothing but magnetic field intensity. So with the current density element, we are going to include a term N vector. Okay, so J vector plus N vector will be del cross H vector. So here we are going to take the divergence for both sides. So divergence now is del dot. Okay, del dot for both sides you are going to take. So del dot del cross H vector equal to del dot J vector plus del dot N vector, which is going to be a 0. It's going to be equal to 0. Okay, because del dot del cross will be equal to 0. Okay, so here the del dot J vector can be written as this current density element can be written as a minus rho V by dou T. Okay, this is one of Maxwell equation. Del dot J vector equal to rho V by dou T. Okay, so here you are going to replace it. That is del dot N vector. Okay, del dot N vector as a dou rho V by dou T. Okay, we understood because del dot J vector equal to minus rho V by dou T. So the replace pannina, that will where you were replace pannina, what will we have done? V equal to 0 layer, the del dot N one side vechittu the minus rho V by dou T and the side கொண்டு போனீங்கன்னா plus ஆயிடும். But del dot N vector equal to dou rho V by dou T னு கொண்டு வரலாம். Okay. So according to your Gauss law, what is Gauss law? Del dot D vector equal to rho V. Okay, this is Gauss law. So here we are going to replace the rho V by del dot D vector. Okay, so just you replace the rho V by del dot D vector in the next step. Okay, so இதுல வந்து என்ன பண்ண போறீங்க? This notation is going to be the change, that is del dot inside எழுதிட்டு இந்த பக்கம் dou by dou T. So dou by dou T with the D vector. Okay, just changing the notation. So now you compare the two sides of equation. So I am comparing the two sides of equation. Here also you are having del dot, here also you are having del dot. Just you remove it. So you will be having only N vector equal to dou D vector by dou T vector. Okay. So according to Ampere's circuit law, you can write the del cross H vector as J vector C plus dou D vector by dou T. So JC is conduction current density. J is the current density. C is nothing but conduction current density. Current density gives the conduction of current. Same. Conduction is moving charge. Okay. So the first term is conduction current density. The second term in this equation, that is dou D vector by dou T, represents current density in ampere per square meter. That is nothing but simply we can call it as a displacement density, or we can say it as displacement current density JD vector. So you can replace the dou D vector by dou T as a JD vector. Okay, that is displacement current density. Okay, so you replace the dou D vector by dou T as simply as JD vector. Okay, so JC vector plus JD vector will give the del cross H vector. So seeing the conduction current density, being the displacement current density. So the addition of these two current density will give the del cross H vector. Now you consider a parallel circuit with the element, the resistor and capacitor, which is going to be in parallel. Here we are going to send receive the current I1 and I2 from the source voltage V. Okay, so the current value for the each circuit will be different because this is parallel circuit. So here the current varying element going to be used. Okay. So with the time period, the current value will change. That's why it's indicated as I1 for this, I2 for this. So the resistor current can be written as I1 equal to V by R according to your Ohm's law. V equal to IR, so I1 equal to V by R. Okay. So this I1 is nothing but conduction current. Okay. Because this is going to be due to the flow of charge. Okay. Flow of charge is conduction. அதனால தான் இது conduction current. Okay. So and I2 வந்து conduction current சொல்றதுல displacement current சொல்றோம். I1 going to access the conduction current. I2 going to access the displacement current. Okay. First you see the conduction current, that is I1. Here the cross-sectional area of resistor going to be A, so that you can write the current density, this conduction current density, JC vector as here. Current density again is current value divided by area. Okay, relation between current and area will give the current density. So in the current patina IC, your I1 going to denote as a IC because this is conduction current irundadanaala I1 வந்து IC nu எழுதலாம். Okay, so IC by A will give the current density value. Okay, conduction current density value. So this can be further written as a sigma E vector. இது உங்களுக்கு தெரியும் current density element is sigma E vector. E is nothing but electric field. So now we are going to ask you, now you come to capacitor. Okay, initial charge of capacitor going to be 0. We are assuming. Okay, so here we are going to apply the time varying voltage. That is, for the time period changes, the voltage value also changes. Okay, so time to time that voltage will be changing. So that will be going to be provided in the parallel plate capacitor. So the current through the capacitor will be given as a I2 equal to C into dV by dt. Okay, C into dV by dt. So due to change of timing and voltage, you will be getting the value of current at capacitor will be C into dV by dt. So now you consider two plates of capacitor area as A, which is going to be separated by a distance D. Okay. So in between that you will be having the dielectric element, okay, with the permittivity epsilon that can be written as I2 equal to epsilon A by D into dV by dt. Okay, C க்கு பதிலா epsilon A by D. To place the C equal to epsilon A by D here. Okay, so this I2 current is nothing but displacement current. So I2 பதிலா ID displacement அங்க என்ன பண்ணா I1 பதிலா IC replace பண்ணோமா. Similarly, I am going to replace the I2 as ID so that the electric field produced by the voltage applied between the two plates is given by E equal to V by D. So, we can calculate the E B, that is V into D into the D. Okay. So, now you are going to substitute the value of B here in the 11th equation. Okay. So, dV play அந்த இடத்துல dV னு replace பண்ணீங்கன்னா you will get this step. Okay. Here D by D, okay, get cancelled to each other so that you will be having only epsilon A into dE by dt. Okay. Now we are going to write the current density element for displacement, that is JD vector equal to ID by A. The ratio between current and area will be the current density element. This current density element for displacement, okay, equal to ID by A. Okay. So here if we take the value of ID in this equation, we will be getting this step. So this is the displacement current. So conduction current. If you add these two currents, you will be getting the del cross H vector. Okay. So here we are going to see the two conditions, that is nothing but sigma divided by omega epsilon is greater than very greater than infinity value, means it will be the medium will be considered as a conductor. The medium is dielectric, then your value sigma omega epsilon will be very, very less the one. Okay. And also for lossy dielectric medium, the current density element, the ratio between conduction current and displacement current density element will give the sigma divided by omega x naught. So note this equation, it will be coming for 2 marks. Then next, general field relation for time varying electric and magnetic field. So the basic relationship between the electric and magnetic field will start from the Faraday's law. That is del cross E vector equal to minus dou B vector by dou T. In the electric and magnetic field order relation using the Faraday law. So already we know that B vector equal to del cross A vector. Okay. A is magnetic vector magnetic potential. Okay. B is magnetic flux density. E is electric field intensity. So del cross E vector can be written as minus dou by dou T. So B vector can as del cross A vector. Okay. Just you are going to interchange the operators in the second equation right hand side. Okay. Del முன்னாடியே dou by dou T பின்னாடி போட போறீங்க. Just interchanging. Okay. So அப்ப என்ன ஆகும் del cross E vector equal to minus del cross dou by dou T A vector. Okay. So in the minus sign in this side கொண்டு வந்தீங்கன்னா plus ஆயிடும். Del cross E vector plus del cross dou A vector by dou T equal to 0. So here del cross is common in both the terms. Indian del cross, Indian del cross. So del cross the general bring outside. So if you bring the out of bracket means E vector plus dou A vector by dou T equal to 0. Okay. So according to vector identity, curl of a gradient of a scalar is always going to be 0. Curl is nothing but del cross. Curl is del cross. Okay. Upper del cross is the curl. Upper gradient. Gradient na verum del. Okay. Curl of a gradient del. So upper del in the del cross del something A equal to 0. A is scalar. A vata B plus C whatever it is. So what's going to be right? Curl del cross gradient del A. Scalar is any quantity. Okay. A B C ஏதோ A equal to 0. அப்ப இந்த இடத்துல வந்து del cross வந்து gradient தான் இது del. Okay. So anyway scalar அப்ப B எடுத்துக்கலாம் A எடுத்துக்கலாம் B எடுத்துக்கலாம் whatever it is. Okay. Equal to 0. அப்ப இந்த term வந்து del B. Okay. Gradient. ஏன்னா curl தான் இது இடம் ஃபுல்லா del B. Gradient of a scalar. Okay. Then del B equal to E vector plus dou A vector by dou T equal to 0. அதனால தான் இதை நம்ம del B ஓட ஈக்குவேட் பண்றோம். புரியுதா? இது வந்து gradient. So gradient term தான் இங்க எழுதிட்டோம். As right hand side of the equation. Okay. Including curl is 0. So negative sign introduce பண்ண போறோம். ஏன்னா எப்படி எடுத்தாலும் plus value இருந்தாலும் equal to 0 தான், minus value இருந்தாலும் equal to 0 தான். It will not affect the equation. So we are going to take the negative sign for the gradient. So E vector equal to இந்த இடத்துல gradient பதிலா minus del V ன்னு எடுத்துப்போம் இல்லையா, minus del V எடுத்துட்டு இந்த இடத்துல plus sign இருக்கு இல்லையா, அந்த சைடு போனுச்சுன்னா minus ஆயிடும். Okay. Minus dou A vector by dou T. We think that this equation has minus sign. Better you put minus sign on writing itself. Okay. போட்டுட்டீங்கன்னா இப்போ இந்த equation plusல இருக்கிறது இந்த சைடு போறாக்க minus ஆயிடும். அவ்வளவுதான். ஓகேவா? So we all know the static electric field will have dou A vector by dou T as a 0 value. Okay. Static electric field. So that it will become E vector equal to minus del V. It is 0 second term, upper E vector equal to minus del V. Now you consider any closed surface, there the current flowing in the closed surface will be equal to I equal to dq by dt. Change in charge will give the, respect to time will give the current. Okay, dou q by dou t. This is ampere unit. இதோட சேர்த்து எழுதாதீங்க, இந்த ampere unit. I equals to dq by dt. Okay. Here we are going to indicate the flow of charge as a positive charge. So we are going to write the equation as positive charge going to be decreased. Okay, internally. So decreasing minus decreased minus dq by dt as I. Okay, so qi internal charge is qi. I indicates internal charge. So if we have to write it for volume means you can write the charge as qi equal to integral of rho v by dv. Okay, this is the charge equation you will be knowing from physics onwards. Physics படிக்கிறதுல தெரிஞ்சிருக்கும். Charge equal to integral of rho v by dv. Therefore, you can write the equation as I equal to minus d by dt into the qi க்கு பதிலா integral of rho v by dv. Okay, just recap the value of qi in the above equation. Just you change the operators. Integral of d by dt you just change பண்றீங்க. பண்றப்ப என்ன ஆகும்? Integral வெளிய வந்துரும், உள்ள வந்து d by dt போயிடும். Okay, that's why d rho v by dt. Okay. So generally you can express the current in terms of current density as I equal to integral of j vector dot ds vector. Now you compare both the equations 9th and 10th. The ரெண்டு current equation compare பண்ணீங்கன்னா you can write that integral j vector dot ds vector equal to minus integral of rho v by dou t into dv. Use the divergence theorem. Okay, what is divergence theorem? You can convert the surface integral ds into volume integral dv னு மாத்தணும். The left hand side la ds clear surface integral அத dv னு மாத்தணும். அப்ப எப்படி மாத்துவோம்? Integral del dot j, that is j வந்து del dot எடுப்பேன். Divergence theorem del dot எடுத்தீங்கன்னா surface integral வந்து volume integral ஆ மாறிடும். ஞாபகம் இருக்கா? Divergence theorem. So line integral surface integral j dot ds vector will become del dot j dot dv. Okay, the divergence theorem. So just you are going to take del dot j for this simple j vector. எடுத்தீங்கன்னா automatically the surface integral will become volume integral. Del dot for j vector எடுத்தீங்கன்னாவே இது volume integral ஆ மாறிடும். மாறிடும் இந்த மாதிரி. Okay, so now both the sides will be having dv. So dv ங்கிறப்ப compare these two equations. What you can write, compute. So இங்க integral remove பண்ணிடு, இங்க dv remove பண்ணிட்டீங்கன்னா you will be having del dot j equal to minus rho v by dou t. Okay, this is the equation of continuity of current in point as well as differential form. Okay, ஒரு point எடுத்துட்டாலும் இந்த differential form எடுத்துட்டாலும் this will be acting as a continuity of current equation. Okay, continuity of current equation. So now we are going to consider Ampere's circuit law. So that is del cross H vector equal to J vector. So far we have seen del cross H vector equal to 0 and cosmos. But in Ampere's circuit law you will be taking an element that is J vector. So divergence in this equation fixed up del dot. Divergence is nothing but del dot. So del dot del cross H vector இதுக்கும் del dot எடுத்துறேன். Okay. So you know that divergence of curl of vector will be equal to 0. Divergence na del dot, curl na del cross. So del dot del cross வந்தாலே that will be equal to 0. எப்போ for the static field, steady state field. Okay, electric field இருக்கட்டும், magnetic field இருக்கட்டும், if it is in the steady state field, it is not varying with the time. Okay, அப்ப வந்து this will be equal to 0. But time varying field இருந்தா it will not be equal to 0. Okay, you will be having some term. So that you can write the property for the varying field as del dot j vector equal to the above equation எடுத்துக்கோம். Del dot j vector equal to minus rho v by dou t. Okay, so the minus value in this side கொண்டு del dot j vector plus rho v by dou t equal to 0. Okay, so இதுக்கு வழியா இங்க பண்ண del dot del cross H vector time varying field எடுத்து வழியா divergence. இதை எடுத்துக்கோங்க. இந்த del dot j vector பதிலா இந்த equation include ஆகும். ஏன்னா இது வந்து பாத்தீங்கன்னா for static field. We are going to write for time varying field. Time varying field, this will be included. This term will be rho v by rho t will be included. அதனால இந்த equation இங்கே நீ ஆட் பண்ணிக்கணும். Okay. According to Gauss law, del dot d vector equal to rho v vector. This last derivation le paathukom. Gauss law, that is del dot d vector equal to rho v vector. So putting this in the 14th equation, this in the plus. Rho v க்கு பதிலா del dot d vector. Okay. அப்ப என்ன del dot del cross h vector equal to del dot j vector plus rho by rho t. So rho badila del dot d vector. Okay. Now we are going to change the operator in the right hand side. Operator na in the ரெண்டு operator na. Rho by rho t del dot t interchange பண்ண போறீங்க. So interchange பண்ணா you will be getting del dot j vector plus del dot d vector by rho t. Okay. So in the two term you will be having the common term as del dot. So bring it outside. You will be having in the bracket as j vector plus del dot d by dot t vector. Okay, இது மட்டும் தான் இருக்கும். So அந்த del dot vector in the left side and as well as in the right side you will be remaining. So finally you will be having del cross h vector equal to j vector plus dot d vector by dot d dot t. Okay. So this is the Ampere's first law for time varying field. Okay. Static field na this will be. இதே time varying field na this will be the answer. We will be including the term with the current density element. Okay. So in the j vector, first term that is due to conduction. J3 னு எழுதலாம். இந்த term இது வந்து current density element due to displacement. Displacement current density element, இது conductor current density element. Okay. So steady state field la pathina, so finally we can conclude that for the steady state element, okay, for steady state field you will be having only the one density, current density element, that is conduction current density element Jc. இதே வந்து time varying field இருந்தா conduction current density element ஓட displacement current density element add ஆகும். Okay, included. இதுதான் finally we are going to conclude. Okay, time varying field as well as static field. Static field na time will not be varied. Okay, ரெண்டு ஃபீல்டுக்கும் இந்த டிஃபரன்ஸ் பார்த்துக்கோ. டைம் வேரியிங் ஃபீல்ட்ல jc plus jd will give the delta H. இதே static field you will be having only jc. Okay.